All right, Algebra 2, we are continuing on with more work with functions. This time is the composition of functions. And what a composition is, it's basically another operation. And it's when the output of one item turns into the input of another. So just kind of jumping into the first example, where you have the radius is 15 feet, is to be covered with topsoil at a cost of $1.25 per square foot in a garden. And what they're going to do is get you to eventually convert that into something else. So the very first thing that they do is, okay, so we have this idea that the radius is 15, but now they're asking you for the area of this garden. Well, just a reminder that area is equal to pi r squared. So if you go to replace 15 into that problem, the area would be 15 squared, which is 225. And it's asking you to round to the nearest square foot. And just a quick expectation for you guys is, well, I guess if you didn't know that 15 squared is 225, you can use a calculator, especially when I expect you to use the pi key, which is found by second the caret button. You hit second first to access all the blue keys. Yeah, so about 707 square feet. Let's write it that way, but I really care about the 707. So that was good. That was fun. That was just one function. But now what we need to do is use that answer to convert it to how much money it's going to cost to, I guess, cover this garden. And the quick answer would be all you have to do is take that answer we got, 707, and multiply it by $1.25 per square foot. Now, I get that this is confusing because I just had the previous lesson talked about when you do function notation, it's the parentheses, it's like f of x. Well, when they're numbers like this, it's clear to me that that's multiplication. So yeah, sometimes what I'll do is I'll not round an answer and then multiply by $1.25, but because of this problem, rounding the first answer, I'm just going to leave it rounded, and the answer isn't much off, but maybe you have to buy a full bag, which is why this might make more sense of $883.75. So that's a pretty simple version of composition function, is two separate problems. And that's really the idea of a composition function, is you have an input, you put the x value in for f, you get an output, but then it becomes the new input for the other function, and then you get your final output. So how do you read this problem? Is we literally read it as f of g of 1. But if you think about your order of operations, you always do the parentheses first. So you need to do the g function and plug 1 in for that x first. And just, I think you can do this in your head, that 2 times 1 is 2 plus 3 is 5. And notice that I did not mess with that f function yet. But we're going to take so we got 5 as our output. That is now our input for the f function. And again, I think you can do this in your head. 5 squared is 25, minus 5 will give you 20. And that is your final answer. And again, that's read as f of g of 1. And I'm actually going to jump down to letter D. I know I'm not going in order. Because the composition sometimes is written with this tiny circle in here. And I know some students look at that and they say fog. What do you mean fog? No, that's the same thing as f of g of negative 2. So you work this problem out the same way. Maybe I'll even use the same colors, that you plug negative 2 into the closer. Sometimes I explain it that way instead of in parentheses first, the closer function. So g of -2 first. -4 plus 3 is -1. And then do f of -1. Just a reminder that when you square a negative, you get a +1 minus 5 to give you -4. So that would be your final answer there. So try some of these on your own. Feel free to pause the video at any point and see if you get a different answer. F of 2, so go to the f function first, because inside the parentheses, f is the closest. So 2 squared would be 4, minus 5 would be -1. And now do g of -1. So we're going to this function. 2 times -1, -2, plus 3 would give me 1. Here's another one that really means g of f of 3. So do f of 3 first. 3 squared is 9, minus 5 is 4. And now do g of 4. So go to the g function. 2 times 4 is 8, plus 3 is 11. And hopefully I haven't lost you. If I have, please write down your questions. But C and F are a little different, but not too bad. You can actually do a composition of something itself. G of 0. And you might actually like these, because if you accidentally do it backwards, you're going to get the right answer anyway, because you go to the g function first and plug in 0. Well, 2 times 0 is 0, plus 3 is 3. And then g of 3, because this g stays there. 2 times 3 is 6, plus 3 will give you 9. F of -1. So go to the f function and plug in -1. Once you square it, you get +1 minus 5 will give you -4. I feel like we already did that one somewhere. I don't know. Maybe we didn't. And then do f of -4. Well, when you square -4, you get +16 minus 5 to give you 11. Fair enough. And we can also do composition functions using graphs. So notice that the f graph is this straight line, whereas the g graph is this downwards parabola, this U-shaped curve. And I've actually had students, and I think this is kind of a smart thing, is they actually list out the ordered pairs so they can quickly identify them. I don't think you have to do it, but make sure you go to the right graph first. So when you see x is 2, and then you want to evaluate f of 2 first, so what's the y coordinate when x is 2? It is 3. So then as you go to g of 3, what's the y coordinate? On the g graph, where x is 3, you get a y coordinate of 3. So if you were doing this, let's say you were a different student that you liked writing out all the ordered pairs. I think that one's 4, 4. Well, you could definitely do the problem that way. Go to the x is 2, the y coordinate is 3, and then over here, if you listed some ordered pairs, let's say 0, 0, 1, 3, looks like 2, 4, and on this one looks like 3, 3. You can say, okay, well now it's 3 for the g graph, and the y coordinate there would be 3. So you can do the same thing on letter B. Do g of -1 first, and that x coordinate when it's -1. Again, I'm going to the g graph. X is -1, 1, 2, 3, 4, 5. So now you have to do f of -5. So go on the f graph, 1, 2, 3, 4. I guess it's -1/2. And you can also do a g of 1, again, just that you're going to the same graph twice. So g of 1 is 3, and then this g stays there. And g of 3 was 3. All right, and maybe I'll do the next ones so you can see. And remember, this is g of f of -2, so you're doing f of -2 first, which is 1. Try and squeeze it right there. So now do g of 1. which that y coordinate was 3. We've seen that one pretty frequently. So the next one is f of g of 0. Go to the g first, the one that's closer, which is a y coordinate of 0. So now do f of 0. Go to the f graph. When x is 0, you get y is 2. And then you have f of 0. So do f of 0 first, which we actually just did was 2. And then do f of 2, which is 3. And this is a good thing if this is easy, but don't be scared to ask questions if you are having any issues at all. Because it only gets more difficult as we get beyond just numbers and ask you to do f of g of x. So as I mentioned, sometimes what I'll do is I'll talk about how you have to do the g of x function first. So what I'll do is I'll just write that g of x is equal to 5x plus 4. So I'll write that out first. But then the other function, which is f, well, let's put it this way, is sometimes in this problem, we'll write this as f of x. And we're replacing x in the problem with g of x. So I need to replace this x with this function. So I'm taking out the x, and I still have the 3 times that function, g of x, minus 2. And hopefully you can tell now, after I would ask you to simplify, but from just writing that, I rewrote the f of x function, except I took out the x, and I replaced it with g of x, which is the whole point of function notation. And what do I mean by simplify is I want you to distribute in there, to get 15x, and then 3 times 4 is 12, minus that 2 would be 10. So just practice simplifying things that you've done in Algebra 1. And maybe I'll explain the next one similarly, but a little bit different. Is sometimes what I'll do is I'll actually write out the g of x function first without the x. So 5 blank plus 4. And what do I need to replace the x with in the problem? I need to replace it with f of x, which is 3x minus 2. So I do want you to simplify that. 5 times 3x is 15x. But now when you distribute, you get negative 10 plus 4 would be negative 6. And another thing I need to point out is notice f of g of x is not equal to g of f of x. So why am I pointing that out? Let me write it here at the bottom. Is order matters. So when you get to a multiple choice question, you might think that you're right because you did, say, g of f of x when the directions ask you to do f of g of x. So the reason why I like this last problem too is you're still doing f of x, which sometimes what I'll do is I'll rewrite it that f of x is something squared. Well, what's that something now? The something is now g of x, which is x minus 5. And especially if it's been a while since you've actually squared anything, that means multiply by itself, and you need to make sure you distribute that x to each piece. So we're looking at x squared minus 5x. Some of you might be familiar with the term FOIL, minus 5x. And a negative 5 times a negative 5 is a plus 25. And I think you can see from there that that'll simplify to option 4. So I'll write off to the side here, option 4. Whoops. And you should be ready for the homework now.